So I always think it's useful to have a quick check of knowledge as we finish the topic. So this is a quiz on alcohols. It's not designed to be a test on exam conditions and using technique. It's more about do you have a good knowledge and understanding of alcohols to finish off the topic. And we'll do another series of questions which will be based more on exam style questions. So we'll have a couple of pages of the questions coming up. So you're welcome to pause these. Of course, you can download this as a PDF file, and then you can have those questions printed out and so on. So the questions are now coming up. So these are the first 4 questions to have a go at. So you can feel free to pause the video if you'd like to complete them. And the final question there, which is a little bit more complicated, does involve more problem solving and is more similar to your exam style questions you may face. So the answer's on the way, so press pause now if you haven't finished them yet, and we will go through them now. So here are the answers. We're going to name these compounds. So the first one, although it's labelled B, is called A. You've got 4 carbons there, so it's going to be butane. The OH is on the first carbon there, so the answer is going to be butane 1-ol. Next one, again, we've got an alcohol there with the OH on the second carbon and 3 carbons in the chain, so it's propan 2-ol. And the final one, a little bit cheeky, but that's a carboxylic acid, 3 carbons, so it's propanoic acid. So time to write some displayed formulae now. First one, 2-methyl-propan 2-ol. So for that one, we've obviously got a 3 carbon chain and then a methyl group on our second carbon here, and you have got the alcohol also on your second carbon. For methanol, you've got a 1 carbon with an OH group. Butanone is, of course, a ketone, and you have to have your carbonyl group on the second carbon. If it was on the first carbon, it would, of course, be butanol, which would be an aldehyde. So we're now going to burn some ethanol in oxygen. So key thing to remember here is, of course, ethanol contains oxygen. When you balance this equation, you form carbon dioxide and water. So you balance your carbons out. 2 carbons means you get 2 carbon dioxides. You have 6 hydrogens in your ethanol, so 3 H2O. And then if you have a look carefully, you're going to have 7 hydrogens, 7 oxygens on this side, which means you have 6 for your oxygen here, because you have your 7th oxygen there. And why are alcohols far more soluble in water than similar sized alkanes? Is because they have that OH group, which is hydrophilic, and therefore can hydrogen bond with water between the lone pair on the oxygen and the hydrogen atom in water. So this is a little bit of a cheeky one, so let's see how we go. We've got an alcohol X, and we're oxidizing it to compound Y, which is a ketone. It does require a little bit of thought, but if you do think about it, when you go from an alcohol to a ketone or an aldehyde, you lose 2 hydrogens from the molecule because we form water, and therefore it's just going to be the molecular formula of your alcohol minus 2 hydrogen atoms which you've lost. So let's have a look at that. Here we go. What's the displayed formula for Y? Well, Y, it tells you, is a ketone. You've only got 4 carbons, so it must be that structure, because as we noticed earlier, if that C double bond O was on the first carbon, that would of course be an aldehyde, and that is the name butanone, as we've said. And when we make the alkenes, what are those 2 alkenes going to be? Well, when we think about if that's where the O is, we've worked that out. So the alcohol would be like so, with this being now a single bond here, and that will be an H. So we could eliminate either this H and OH or we could eliminate this H and OH. So the two alkenes that can be produced are going to be but-1-ene and but-2-ene, depending on which hydrogen is eliminated with the OH. And if we look at this compound, or just from looking at the question, if we make a ketone, the alcohol must have been secondary. So there's the structural formula for X with the OH on the second carbon. And to oxidize that, we would use K2Cr2O7, and it would be acidified, and it would go from a lovely orange to a murky green colour. So I hope you found those questions useful. A nice little quick test for you, just to check that you've got the basics before we go on to some more complicated questions. And please do download this for your notes from the website. It's always helpful to have these things when you come to revise for the big exam at the end of your A-levels.